So very good morning. We are at the end of this 6-day webinar, but still some more concepts like whatever the questions raised by you in yesterday and day before yesterday, that and all will be tried to answer now, So there was one interesting question that how to do bootstrap. So uh, I tried to doing that, but fascinatingly, I found many packages which are available for doing bootstrap. Each package for its own purpose. You have LM boot, you have WBoot, you have bootstrap. Okay, like this, you have different packages for its own application. But when I started doing a lot of homework, all these things, so once I won, and then I came to know that WBoot will help us to do very easily. And I have found 2 to 3 set of different methods of doing the bootstrapping, particularly with respect to inferential statistics. Suppose if you want to do bootstrapping, there is what we say, a modeling aspect. There is a package called LM boot. Okay, so like this, for modeling aspect, you have one package. For inferential aspect, you have one packet. In general, if you want to write, you have to execute the total functions what you have written into a loop, then also you have a bootstrap package. Okay, so like this, based on the need, you need to choose the appropriate package. Now the question was that how to conduct a t-test, I mean bootstrapping in t-test. Okay, that there is a function called boot.t.test. Okay, and when I started running that, there was some errors. I admit that. But later, I found there is one package called Lycra DWboot. Okay, so this will help us. This will help us. This will help us to do a lot of bootstrapping for this particular inferential kind of a procedures. Okay. Okay. Fine. Now, before you do apply a bootstrap technique, we should come to know what actually a bootstrapping stands for or bootstrapping means to. Bootstrapping and jackknife are two important techniques available in the total hub of resampling procedures. Resampling is nothing but making use of the samples which are available at hand and then fitting the technique for multiple number of times to see the precision of the estimate in terms of bias and standard error. Okay, so what do you mean by this? Bootstrap is nothing but making use of the samples available to you, okay, for repeatedly for n number of times. When we have to go for I mean, as per my knowledge goes, the application of bootstrap comes in multiple situations. One thing is whenever your experimentation cannot be repeated again because of cost, because of time, or because of other factors which prevail you to restrict, not you cannot repeat that particular experiment again. Then whatever the samples you have, let us take you have 25 samples in your experiment, but you have built a model on that, or you have you have computed a kind of inferential statistics out of that. Then in such case, in order to generalize the phenomena, in order to see the precision of the total outcomes, okay, you need to repeat the experiment. But is it practically viable? May not be. In most of the cases, again, repeating the practical experimentation in a general, especially in all disciplines like life sciences, social sciences, especially survey-based studies, it is very difficult, even in life sciences, working on albino rats, working on different crabs, rabbits, different now things are there. Working on them again is a very cost-effective phenomenon. So then what you have, use the data which is available with you. Okay, then randomly pick some portion of the samples and then do the computation. store that particular estimate like mean, standard deviation, and keep it aside. Likewise, how many times I should do? Like B bootstraps, capital P, boot, that is what we call resample. Now, once the computation is done, put the sample back into the total main sample. Again, second time, you pick another sample which is at random, again do all this computation. So at every point of time, what you do is, let us take 50 samples are there. I'm drawing randomly some samples at, right, let's take around 30 samples I'm drawing, some portion of the samples I'm drawing, I'm estimating the measures and storing it. Again, like this 100 times I do. Every time I pick the sample, I'll get a different set of 30, 30 subset of observations. Okay, this is what we call making use of the available data and strapping the data, strapping the data with the data set available to you and providing the precise estimates and measuring them with respect to bias and standard error. You have bootstrap mean, you have bootstrap standard deviation, you have bootstrap mean square error. So that mean square error or standard error will tell you that as minimum the bootstrap mean square error or lower the bias, then the actual estimate and the bootstrap estimate are very close by. Okay, actual estimate, let us take theta cap. Let us take, we will denote like this mean. Okay, mean of one particular variable is your actual estimate you have computed from the data. You have, let us take 100 bootstrap you have run. The average of those 100 bootstraps is your bootstrap mean. So if the difference of this is very close by, okay, if difference of this is very close by, then it is what we call the bias is minimum. Bias is nothing but the actual value minus the estimated value, or observed value minus expected value. Okay, the difference between the actual estimate and the bootstrap estimate will speak you about bias. Okay, so bootstrapping is very, very important. Actually, there is a small story behind the name of bootstrapping. You might have seen the long boots, okay, where you want to strap that particular boot using the holes or the straps which is available to you. And so I'm not able to explain that properly. But anyway, in a statistical perspective, what I can tell is it is a simple notion to understand that building, constructing the model or constructing the set of inferential hypothesis testing using the available data with multiple number of times, that is with multiple number of times. It is a concept called simple random sampling with replacement. I have 50 samples. At every bootstrap pickup, I will take some proportion of samples, then do repeatedly like this. So doing this, we are generalizing the phenomena that if this kind of experiment is conducted in the same identical condition, then my estimate will be within that particular confidence interval. That's why potential uncertainties. The mean square error, if it is minimum, that all the bootstrap estimates that you have computed from the total experimentation will give us a very precise information, a kind of accurate information to speak about your experiment. Okay, so with this gentle introduction, we start understanding what we have done so far in t-test and what the difference comes with what we say this bootstrap. Let me share that. Fine. Now we have, I will show you two different methods. You can understand which one might be comfortable to you. Let us see that. Okay, well, sorry. Okay, now this is the data set we are using. This already we have worked with this data set. That is what the data set has, the bone strength of different age groups, right? Now let us load the data, and then this is the conventional way of t-test what we have done. Okay, and now from here after, Hereafter, we will do slowly and point by point, we'll understand the technique of bootstrap. Okay. The first thing is your age group is having categorical information like young and middle aged. Okay. First, you have to define them as a factor. Okay. How to define as a factor? Factor f the sleep variable, I mean sleep data, calling age group and label that age group as young and middle aged. Now I'm using a library called boot. Okay, I'm using a library called boot. There are different packages available that I'll come to later, go to that later. And there is a package called library boot I have installed and I'm using that package. Now, first we have to use the function tapply. Tapply is nothing but it will give the means of, I mean, this is a summary statistic in the form of a table. Okay, calculate mean across these groups. This is the continuous variable, this is the factor variable. Okay. Now, what process we are trying to do here is look at the hypothesis. What is the hypothesis we do? The average bone strength. That is, in general, we write like this. Let me put it in H naught. H naught is equal to mu one, or mu one corresponds to bone strength of young age group. Let us take mu one is equal to mu 2. So this mu 1, mu 2 corresponds to the average age of young age, average bone density of young age group and middle aged group. Now, this is the population parameter. Now, how about the sample statistic? This, the about a hypothesis should be measured with sample estimates, that is what we call x bar of 1, that is x bar of young adult minus x bar of middle aged group, so which is equal to 0. That is what we are trying to measure now. So do we need, we are testing that the average difference obtained from the data between young age group and middle aged group is equal to 0. That is what we are trying to address now. So to do that, first we have to compute means. This is what we have done. And even in the t-test statistic also, the numerator part is nothing but the difference of means, x bar 1 minus x bar 2 or x bar minus y bar, whatever the notation you take. The first mean corresponds to the average of first population, second mean corresponds to the average of second population. Okay, in a population parameter estimate, we define them as mu 1 minus mu 2. The next step, what we have done is, this is what we have done. We have calculated the difference of bone strength in first group minus the average difference of bone 2, I mean this in middle aged. So this will give us, it is around minus 18.1556, means the middle aged group, the average bone strength of middle aged group is comparatively lesser than the average bone strength of young age group. Okay, now we have got the numerator part. Now, next what we have to do is we have to run the bootstraps. I mean, we have to define a function which will tell for multiple bootstraps. Okay, so in order to have this bootstrap function into comparing two sample t-tests, we need to write a small lines of R indicating that you define T, that is that you define means. Means is nothing but you are storing this information. You are storing this information. I mean, you're calculating average at every step of bootstrap. At every step of bootstrap. That means whenever you take the sample, calculate the mean, store it in the means. Okay, calculate the means of what? Calculate the means of middle aged and young and store it into mean. and from that mean, return means of 1 minus means of 2. What does it mean? This step we are mimicking here. Okay, we are focusing on the numerator part of the t-test, that is difference between two group means. Okay, that is nothing but your effect size. How far on an average two groups differ. Okay, now once this is executed, now we use the function called boot, which is available in library boot, where we have to give the original data and we have to call f. I mean, f contains all the necessary computations with respect to the difference of means. Now, r is nothing but resample 500 times. I am instructing the R environment that I'm instructing here to draw out of the data, out of the sleep data, what is the sample you have, repeat 500 times you resample the data. Okay, first time you resample, compute means, and then take the difference, store it. Again, go back, keep back the sample into the main data. Again, pick from some random sample. Again, compute the necessary computations which are given in F. Store it again. Like this, it will do 500 times. Okay, it will do 500 times. So all the differences will be stored in this bootstrap difference. Okay, let us do this first, and then we'll go for the another method uh, of understanding. Yeah, so here, don't worry about this. Yeah, this is stratified bootstrap. This is the call, and this is the original, and bias is equal to 0, and standard error is almost 0. So what how to understand this is, the original estimate is minus 18.155. The bootstrap estimates, okay, when we take the difference of that, they are very close by. Very close by, and the bias is almost 0. That means the true estimate is equal to the bootstrap estimate. Okay, means here one question to answer that, why we have to do only with respect to the means, right? Because the the most of the time in t-test, we focus on the average difference of the two populations. That is what we call effect size. That effect size is very, very important to focus in statistical inference, particularly in hypothesis testing, because that numerator part will tell you whether the effect size which is observed, the mean difference which is observed, is really a noticeable change due to chance, or do they act similar? Do they act similar? Just observe, I have two normal population, one population for smoking, one population for non-smoking. And you have a two vertical lines which indicate the mean. Now, I'm computing differences. If the differences are very close by, then the behavior of the smoking population and non-smoking population with respect to the measuring characteristic, let us take sleeping time, is completely overlapped. Papa, you are getting it, right? Now, as closer the mean difference, as nearer, as less smaller the mean difference, then you cannot reveal out that there is no, you cannot reveal out the true, you cannot claim that the sleeping time do vary across the smokers and non-smokers. Okay, now as the mean difference becomes larger and larger, wider and wider, the vertical means are little farther and farther, you will get a minimum overlapping area, giving rise to the meaning that as larger the mean difference, you can clearly claim your statement that the sleeping time do vary across the smokers and non-smokers group. Okay, that's why in this bootstrapping of t-test, we have to consider the difference of means and then run that particular differences for different resampling samples. Okay, this is one method of doing. And then there is another method which is called library DWboot. This is very interesting package. It has multiple functions and arguments and objects that are to be covered. But as of now, I have covered 2 to 3 functions in this. Let me make into one line so that you will understand. This package is very quite interesting, really quite interesting, and we need to see a lot more. Okay. Now there is a package called WBoot. Okay, there is a package called WBoot. In that, the function is boot.to.bca. Okay, so here 2 is nothing but corresponds to 2 samples. Boot.to.bca is nothing but corresponds to 2 sample, and this is the of measure of observing how to compare two groups with respect to bootstrapping. And I'm calling how to call this. The first argument should be of one group, that is n group. The second argument should be of another group, and I want to compare across the mean. See, here also mean only. Okay, here we have done little raw compute, crude way of very crude way of computation, but here in WBoot, automatically just we have to give the statistic mean. And stacked is false. Stacked is nothing but you have smokers and non-smokers. This is stacking. But here in this data, what I made is, suppose if my data is in multiple columns, what should I do? Okay, so then you define stacking is equal to false. And variable bone strength and confidence interval for testing, for having the bootstrap confidence interval is 95 percentage. Is nothing 95. And you can define, when I keep this, you can define alternatives also. You can see this. Alternative is equal to two-sided, less, greater. All the things what you can do in general t-test, you can do here also. Most majority of the arguments are very similar, but only one thing is you have to, you can define resamples also. 999 maximum to 9,999, you can define the resamples. But here, by default, it will take around 100 of time thing. I can define that also later. Okay. Now let us run this, for which I need some space for graph. What is that? Why? Oh, I have to store the data. Sorry. I have not taken the data. Yeah, I got it. I have not loaded the data earlier. And this is the total outcome. This is the total outcome. By default, it has taken 9999 replications. So the data is bootstrapped for 9,900 times. Okay. Now the summary statistics, all what and all, the population 1 is this thing, population 2 is this thing, the number of samples in first population is 10, second population is 10, difference of mean observed is 19.949. Okay, and the bootstrap mean is 19.54. Okay, and standard is 11.986. And see the bias, it's 0.05. It is 0.05, very small, very minimum bias. So we can claim that estimate 19.49 is a precise estimate and accurate, unbiased one, that we can talk about the total thing. And confidence interval, when you talk about this confidence interval for the mean difference, confidence interval for the mean difference. Now, how to understand this graph? See, this is the two vertical lines which are colored with the shaded blue is called this 95% confidence interval, and this green line, and there is a small line of red also, that because it's very tiny, I mean, depth is very small. So this is nothing but observed and mean of the bootstrap. Okay, both are under nearer to 19.49, 19.54. So they are totally overlapped here. They got totally overlapped. Some more experimentations are to be done with this package, that to see with the different non-normal things, and then how to show that how the bootstrap variation will be equal to the observed estimate, something like that. Some other experiments can be done, but just here the point is to address your question that how to run bootstrap in a particular T sample T test. Okay. I mean bootstrap with respect to 2 samples. Now this is the confidence region, this area, what we call, these are all the some samples which are above the 95% confidence interval. Okay. Now let us do some more thing that I want to show you the variation with respect to the confidence interval. Okay. Now my interest goes here. Look at this. This is 95%. This is 99%. So most of the time we try to explain that what do you mean by 99 percentage of variation, what is 95% confidence interval in defining the acceptance region and the rejection region, right? See, as you widen the area of accept, as you increase the percentage of level of significance as 99, your vertical lines are little farther and your rejection region has become so smaller. Okay, so the choice of 95, 99 is purely into the investigator knowledge, because it purely depends. There was a question that yesterday, that's is that sample set determination is required before you conduct a study. Necessarily, because because all these things will depend like this here. Suppose if you choose 90% power, okay, and 90% power and 5% level of significance, then automatically you are claiming that whatever the data you have, that will speak very precisely and will provide accurate information. As you lower the power, okay, as you lower the power, then the preciseness of your data, the power of that particular data, the power of the test which you speak about will become smaller. Okay, the concentration, if you see here at 99 percentage, you are able to observe two vertical lines, one with green and one with red, right? So this is this minute difference of the original estimate and the bootstrap estimate. Observed is red and bootstrap is very next to it, very close by access to this bootstrap estimate. But whereas with 95% interval, they are very totally overlapped. Okay, so with this so what we understand now, look at this. This is the actual estimate, 19.49 with respect to 99% confidence interval, and 19.22 is the 19.22 is the bootstrap estimate. The bias is minus 2.67, minus 2.61. That's why the vertical line was little on the left side, I mean, very close by to the left side of the actual estimate. Okay, so now when come this boot.2.vca, this particular wboot package will give you very nice information that what is your actual estimate, what is your bootstrap estimate, and then what is the confidence interval of that particular mean differences, and how the histogram plot of the total bootstraps will act. So all these things very nicely present can be presented. So this was the question, and I made my attempt to address that particular question, how to do. And to do ANOVA, there is a package called lmboot, where you have an argument called anova.boot, where you can test that also. But let me see if there are some other arguments even I have to learn for doing all necessary bootstrap. So with this gentle introduction and conceptualization of this bootstrap in t-test, okay, we will, I mean, I'll stop sharing now. Okay, I'll stop sharing now. Uh, Hope by this time you might have received, hope by this time you might have received the data files. Okay, okay. So my request is kindly start working with that. Okay, and start working with it. Once you practice, just listening will make you aware that how the techniques to be used, how the things to be used, all these things. But when you practice it only, you will come to know the errors, issues in that. Okay, fine. So any questions for this today's discussion? Or in general, for the total 5 days, do you have any question to raise, any clarification you want? So today afternoon, what is my plan is, today afternoon, what is my plan is, you start practicing from now itself. Okay, if you have a doubt, immediately you share your screen. Okay, share your screen so that I can address the question. Excel Connect package. Uh, I should read just like that. I have not gone through that Excel Connect package, madam. Okay, but I have to look into that. Without replacement means, see, the main purpose of bootstrapping is to resample the data with replacement. When you exhaust your sample, there is no fun in having bootstrap. So generally, this sample, simple random sampling without replacement comes in this. Without replacement is quietly less applied in most of the situations. Okay, the very basic purpose of bootstrapping is to make you to conduct the test statistic or the statistical method which is of interest for multiple number of times with the existing data what you have at hand. Generally, repeating or collecting the data one more time to see whether the estimate will be in a general condition or not, it is a cost variable. Okay, it is a cost effective and different factors come into the picture. That's why we go with this kind of a resampling technique. Jackknife is also available. Jackknife is also available. But in medical field, that is the best way with replacement. So in medical field, it is uh, most of the time you go with replacement only because getting a samples from the patient, okay, okay, and is very sensitive. And for a particular, let us take spine data or a particular kind of a disease problem, you will get a very let us take 10-15 samples in a year of time. Then it is very cumbersome, very complicated task. Okay, if you do with simple random sampling without replacement. So with the available data, which is collected on a very with a precision, you apply this bootstrapping to model your data. What are the issues of files? I didn't say any files. No. That was, I have not called the first, I have not loaded the data. Before that, I started running the code. That's why the question was. Okay, that's why the problem of data file was there. That's it. MLE, maximum likelihood estimation. Okay. See, this is one of, there are 5 different methods of parameter estimation. Method of moments, method of likelihood estimation, and method of minimum chi-square, something like this. Okay, that method of likelihood estimation is one of the important method which enables us to obtain the estimates from the data from the distribution. Okay, so actually what are in real analysis, I don't know it, I'm sorry. Real analysis, convergence of sequences and series. I think we can create our own functions rather than using built-in function. Definitely with replacement will give accurate result. No. See, the thing is, the bootstrapping with replacement, so there are two different things. We are trying to use the bootstrap technique to see whether the original estimate, when we repeat the experiment for 100 times and we have original estimate, whether that original estimate will be equal to the bootstrap estimate if we conduct multiple times. If the experiment is conducted for multiple number of times, if the bootstrap estimate is not close to the original estimate, then we have to see that the original estimate is little biased. Okay, that will talk about the property of the estimate. And when it is close by, then automatically the obtained estimate is unbiased in a general phenomenon. You can start claiming that particular outcome. Yes, Karnam Lakshmi raising a question that can we use R to solve operation research? Yes, we can do. We can do. If it is okay, then I'll share. I will show you a quick glance of. Recently, I have given a talk on that. Let me try to show that. We can have that also. For another program, I have given this particular linear programming, but it will take longer time. I took for almost 1.5 hours. Okay, let me try to share that. This here, if this is the linear programming problem, first thing is you have to define the parameter. Parameters are nothing but your objective function values. Okay, and then you have to define the constraint matrix. This 10, 20, 120, 70, 7, 10, 8, 1, 1, 1. And then you have to use directions like less than, less than, less than. If it is greater than or equal to, you have to give greater than or equal to, less than or equal to, and equal to. So in one stretch, you will be covering all the three procedures like simplex. If the here it is a simplex method. Suppose if any one of the inequality is greater than or equal to, it will become two-phase method. Sorry, big game method. Okay, two-phase or big game. If it is equal, there is all combinations of less than or equal to, and greater than or equal to. Then it will become two-phase or big game method we can use. But in general, in R is the common base here. Now, right-hand side constants we have to define. Once we define, we have to call a package called LP solve. And this is the one line of argument. That's it. LP. First argument is maximizing or minimizing. Objective function we have already defined. Constraints also we have defined. Constant directions also we have defined. RHS also we have defined. And to have a sensitivity analysis, you can have additional argument called compute.sensitivity is equal to true. And this will give success. The objective function is 3250. That's it. Now, how to know that each and every x1, x2, x3 are the decision variables? To know that, we have to use solve dot dollar solution to know the decision variable values. So it was x1 was 250, x2 was 625, x3 was 0. So in total, this is the actual and computing. This is what we got. So similarly, we can have an infeasible solution where I'm defining all the matrix operations. Okay, now, since see here, when we make graphically x1 plus x2 less than 5, x2 greater than 0. So when you have a graphical plot, x1, x5 will come like this, x2 will be something like this. So there is no intersection of these two lines. So definitely it will be infeasible solution. So if it is that, it will tell you that error, no feasible solution found. Okay, like this transportation problem also we can do. Okay, we have to define, this will take time, but very quick I can go, that you have to define all these things into a vector form, and define some looping structure we have to take, and then define constraints, define right hand sides. Okay, and then we have to convert this table into this kind of a matrix. I mean, this kind of objective function and subject to constraints. Then only we can do all these things. So we can solve transportation problem with simple 4 to 5 lines of our code. Okay, that even this is the optimal solution. This works with Ozel's approximation method. This is the after applying Modi method, it will give the solution. Final assignment, final transportation thing. Okay, and apart from that, you have a trans package also where we use this northwest corner rule and least cost entry method. This is minimum cost. This is nothing but least cost entry method, and this is northwest corner rule. Like this, you can explore. There are packages available for for our packages for this thing also, what we say, operation research. Okay. Oh, too many questions have come. Can you suggest any available package to work on topic like grandeurs, uh, especially time series and econometrics? I have no idea, sir. You can write to me. Definitely, I will try to support you in the best way to make use of these related packages to explore more. Okay, Yogesh Bhaji, you can write to me about your this request. I will address that problem definitely. All the Rajita madam is asking all multiple multivariate techniques in one question. Each and every technique has its own package available. Using that, we have to do. Okay, that's what yesterday I said. I'm ready to support you all. If anyone is ready to host, I'm ready to assist that particular thing. Sandeep G in MLE LBFGSB method. What is the meaning that why they use? I will make a note of this. Kindly mail this question. Introduction to Bootstrap by Tipshirani, Efron and Tipshirani, Bootstrap textbook. Okay. Torah is easy compared to this for LPP. Torah I have worked in Excel Solver. I have worked, but I felt R is more comfortable than Torah or Excel. Okay. Anyway, because I am tuned to programming, so that thing. Okay, good questions are coming. Each are talking about each dimension. One is talking about OR, one is talking about quality control. Okay, in simple, how to tell. Okay, examples based on quality control. It is a very general question. In simple, I can tell that in order to claim the, whether the good is of quality or whether the production process is of quality or not, it depends upon multiple characteristics of a commodity. Okay, so the thing is, when you take a mobile phone, you uh, different factors do play a role there, play a role there, that you have the length, you wish to have this much height only, I want the mobile should be, the width, the breadth should be smaller, the width should be this much, and the screen protection, weight, aesthetics, color, features, like this. Okay. Fine. So maintaining quality of these items will become the process aspect of the manufacturing. Sorry, I cannot make this very clear now because your question is too general. Yeah, Nagaraja, we'll have one more webinar on multivariate analysis. That's what I said. I am ready to assist, okay, to any institution if you wish to organize. I am ready for that. To the best of my knowledge, there is no textbook for statistical case studies. It depends upon the domain you choose. Okay, so if you see management, statistics for management by Levin and Rubin, where you have different exercises and case studies very nicely explained. Okay. Can you please share the script for PCA discriminant cluster analysis? Madam, I have to trace. I have worked a little back. I have worked on those scripts, but I will share them. I will share them, but I have to tune that first, and then only I can share that. Best book for how to create a package in R. Sorry, permit. Okay, even I'm also trying to create a package of one of my research activity. If you know, let me know. I admit that. Sorry. Okay. Can you please share that? Suggest the book in which book for is a statistics or Sandeep Sainji? Is it the book you are asking for or general phenomena? Our script is nothing but whatever the programs what we have seen, that is what will the script. Script is like a notepad. Everything, all the 5 days sessions I have shared to the organizers. They have shared. If still you have not got, kindly be patient so that it will come to you within a short period of time. Okay, don't worry. Okay, I can understand your thing. Books for biological aspects and biostatistics. Biostatistics by, I can show you. This is the very good book. Biostatistics by Van W. Daniel. Biostatistical analysis by Zerold H. Zar. Excellent books for understanding biological. And moreover, I have, uh, you can see, I'll show you one more thing. Okay, I'll show you one thing. This is my platform to do. Okay, hope you are looking at one textbook, Multivariate Statistics Made Simple, a practical approach, which was written by me as well as my professor. Okay, this will contain multivariate statistics made simple by K.B.N. Sharma is my guide, under whom only I did my PhD, and we together worked on this particular things to make it multivariate statistics more simpler. Totally, we have worked with real data sets. Okay, and this chapter, this okay, and yeah, coming to the contents here, yeah, we started with what is the overview of multivariate statistical technique, then how to compare multivariate means, that is about t-square and paired comparison about the multivariate mean vectors. Then we spoke about ANOVA, and then, okay, there are some copies missed here, but then we spoke about multiple regression and its diagnostics, logistic regression, okay, ROC curve analysis, and then binary classification with linear discriminant analysis, logistic regression, survival, and we have Poisson regression, and we have cluster analysis. Around 12 chapters dedicated purely for this, uh, what we say, the multivariate techniques. Okay, so you can have a look of that. Okay, and yeah, this is the description. Advanced but essential concepts of multivariate statistics in a practical way with a touching mathematical logic in befitting manner. This is what we try to do. And okay, so this is one book where you can have a very simple way we made our attempt to explain, okay, the things. And one more textbook for univariate. There is one more textbook for univariate from, Yeah. So this is my professor's first book, Statistics Made Simple, Do It Yourself on PC. So then the book which I have shown now, that is extension. This book covers all the univariate approach. The next book we have covered all the multivariate approach. Okay, so you can see very good. Very here also he has used very real time data, very easy way of understanding statistics with a blending of the mathematical touch. Okay, so already this book got out of stock for multiple times. Again, the print is all has printed for multiple copies, 4 to 5 times. Okay, this is the best book for very beginner to understand how to look at statistics. Okay, and in this book, the previous one, in this book we have touched upon the essentials and crux of all the multivariate techniques. Okay, so you can make use of these two textbooks for better understanding. Okay, we have used Excel. We have used this. We have used it for this SPSS and R. Most of the time we have worked with R package only. Okay. Textbook for best book for R, I said no. The title of this thing is nothing but discovering. We can write the R book by Michael J. Roll. Okay. So this is one best book, Biostatistical Analysis by Zar. Okay, very nicely starting from the scratch of the statistics, basic statistics, probability distribution, graphs. Okay, all inferentials, regression, repeated measures, like that they have covered very nicely. And another book what I wish to tell is by Daniel. This book, I think the recent edition, 11th edition. I have 9th. I have 9th edition. It is 11th now. This is also a wonderful book. Okay. Any questions you have? Hope by this time you might have received the data sets. If not, be patient. It will come to you. Start practicing. Today afternoon we'll have a case study presentation. I mean, case study presentation, nothing but what I wish to say is given a problem, how to tackle it. Okay. And then how to choose the appropriate technique. I will take another data. Then from the data, I will tell you how to choose the appropriate statistical technique and how to go on with that. I will not do any programming in the afternoon, but just I'll make you aware that given a data, what is the thought process it should start into you. Okay. Best practical economic data analysis using R. Okay, I should look into that. I am not aware of that econometrical data analysis. I mean, I know the total modules of econometrics, but so far I have not worked with econometrics with R. Okay, okay. I have valuables in SPS. How can I import? Valuables or variables? So sensitivity value labels. Okay, see, we have to define numerical. I think when you import SPSS, it will come directly in a label format only. It won't give in the value format. I have tried once, it has come to me with a label format only, not with the value. Okay. How to explain sensitivity analysis in R? Sir, it depends upon the context, but just making you how to do. Explaining sensitivity analysis is in general, but using R may not be the correct one. How to compute sensitivity analysis in R? That is what you mean to tell. Explaining or understanding sensitivity, that output of any software, you can start understanding it and explaining it. How to do sensitivity analysis means, see, in transportation problem, you have an argument. There you have a sensitivity analysis of all the programming problems there. Likewise, for every thing, you can have the sensitivity analysis there. Okay, if there are no questions, we'll wind up this morning session. So afternoon, sharp 3 o'clock, we'll meet again. There we'll have, if a data is in front of you, how to take a look of the data and how to choose the statistical technique out of that, and how we can meddle with the data. Thank you so much.